Unconfined surface aquifers. Don't get unconfined, which is the top layer up here, mixed up with confined aquifers, which would be down here. A confined aquifer just means it has something impermeable above it. Say this is like shale, and something impermeable below it, like it could be shale or bedrock down here. But the water can't go up or down very easily. Again, shale is very impermeable, so the water can't go through this layer, top or bottom, so it's confined aquifer. We're looking for this unconfined aquifer, meaning there's nothing between the surface and it. There's no impermeable layers. It can freely flow and get down here. So with the unconfined aquifer, the first one is an aquitard or aquiclude at the top. Well, this impermeable layer is what they call an aquitard at the top. It slows down the movement of water through that layer. So we would not check that. The unconfined one does not have that layer at the top. Artesian wells. In artesian wells like this one here, it's a well that goes down to the confined aquifer, and it's under pressure. And because there's a layer up top that keeps water from moving to the layer at the bottom, it fills up this like a water tower, and so the head level of the water will be uphill from it somewhere. The recharge zone will be up here, and it fills in up here where it can easily get soaked through the ground and get down to this layer. It doesn't have to pass through this aquitard, and so the head level will be up here, and all those molecules of water are putting pressure on the lower water down here, and it puts pressure on the well, and that water will rise up the well up to the head level. And if it comes all the way up to the surface, they call that a free flowing artesian well. But even if it doesn't make it all the way to the surface, it's still an artesian well as long as it's under pressure. But that would not be something we select for unconfined aquifer, surface aquifer. The water table, that is something that we have. The water table is a term we use for our unconfined aquifer. Remember our unconfined aqua man who was wearing the fur coat. He had the party that he was doing, and he had the air and raisins and the balloons above the table, and he had the water on the table, and he had the satin raisins underneath the table. So the unconfined aquifer, the one who'd like to throw parties, he had the water table and the zone of air and raisins or aeration above it, and the zone of satin raisins or saturation below the water table. Saturation just means completely wet. So this zone down here, all of the empty space is full of water. It's like a bathtub. You know, at the surface of the bathtub, that would be your water table, and it's completely wet beneath the surface. So it's your zone of saturation, and then there's just air above it. So that's the zone of aeration. So we do have a water table. We just said we have a zone of saturation and aeration. We'll both check those off. Recharge zone is upslope, not directly overhead, or recharge zone is directly overhead. Well, the recharge zone is where it rains. Will it fill it back up? And right here, if it rains directly over this area, the water will percolate through the ground and then start to fill it up like a bathtub. The recharge directly overhead is something that we have for our surface aquifer. Our confined aquifer down here, which again, we're not selecting that, but our confined aquifer, that's where the recharge zone is not directly overhead. It's upslope somewhere, uphill. I like to say up in the mountains, but it doesn't necessarily have that. It just has to be somewhere farther uphill where that shale or that aquitard, aquiclude, rises up and hits the surface. And then we can see over here, this would be the recharge zone where it doesn't have to pass through that impermeable layer to get down and fill this up with water. So we want to go with the recharge zone directly over the aquifer when we're talking about this unconfined aquifer at the top. Drawdown, that's just a problem that we have, and most of our well problems are going to be with the unconfined surface aquifer. This artesian well over here, they're the nice ones. They're the nice ones that you want to have if you're a homeowner. Because they're deep down, and so they don't have problems like pollution, because again, you've got this impermeable layer. If water can't get through it, pollution can't get through it. You're not going to have problems with drawdown either. Drawdown is when you over pump your well, and you'll have a little area that will basically, here would be your water table right here. It'll pull that water table down and have a little indentation. It's like if you put a straw in a milkshake and you suck on it, and it goes empty, even though there's plenty of milkshake around it, and you got to move your straw or shake the milkshake a little bit to get back in your straw. Kind of the same thing. You pull the water out faster than it can move back into that area where the straw or the well is here. The reason being is because you've got grains of sand. The water molecules have to move around those grains of sand to get back into this area, and so it goes very slow. So that drawdown, where you pump the water table down a little bit around the well, that is a problem with unconfined. You don't have it with confined aquifer because it's under pressure, and as soon as you pull it out, the pressure around it pushes water back into the well nearly as fast as you can pump it out.